Well, hello and welcome to another amazing video by your incredibly handsome science teacher, Mr. Bertoch. In this video, we are going to talk about fields, electricity, and magnetism. So let's talk for a minute about fields. First of all, what is a field? Well, it is a place with a lot of weeds and grass, but that's actually not the kind of field that I am going to talk about. The word field can be used a lot of different ways. So we do use it as a place of weeds and grass that goes on forever, but we also use it to mean a force. If you've ever watched the movie Star Wars, for example, you see where they control things using the force from a distance. So a field is a force that allows objects to interact with each other from a distance. Okay, it is a good thing that I do not have the force, like on Star Wars, because if I did, I would get really fat because I would sit there and make myself a lot of sandwiches and make them come to me and go into my mouth, and I would never do anything. So that's probably why I don't have the force. But a field is the ability, it's a force, it's the ability of objects to interact from a distance. And you are familiar with this phenomenon. If you've ever used a magnet, for example, magnetic fields, they are objects like a magnet and metal that are able to interact with one another from a distance. Another type of field that you are probably familiar with is called static electricity. So if you've ever taken a balloon and rubbed it on your noggin like that, back and forth, well, what happens to your hair? I mean, in my case, not much because I'm losing my hair. But for those of you who have hair still, I mean, I have some. What happens to your hair when you rub a balloon on it and hold the balloon above your head? Your hair is attracted to the balloon. And if you take the balloon and put it on the ceiling or the wall, then the balloon becomes attracted to the wall, almost like it's a magnet. Okay, but it's not a magnet. It's static electricity, another type of field. So a field is when two objects can influence each other from a distance. They have a field around them, like an invisible force that's reaching out across the distance, like two invisible hands coming together, and because they're in love and they hold hands from a distance, but you don't see the invisible hands. Okay, that's a field. And the two fields that we are going to talk about, there are more than two in science. But in this video, we are talking only about magnetism and static electricity. So let's start with magnetism, since that's the one you're probably already most familiar with. Magnets are these little objects that have a magnetic field around them, and that magnetic field is always around them. So even though I might have the magnet sitting alone on a table, and it's not currently interacting with anything because everything's too far away from it, the magnetic field is still being generated around the magnet. They're really kind of cool. And when I take two magnets and put them together, they're going to do one of two things. Okay, can you predict for me what they're going to do? What are the two things? If I bring two magnets together, they're either going to attract to each other, pull closer together, or the other thing they're going to do is they're going to repel. They're going to push each other away, depending on which poles are facing towards each other. So you've probably heard the phrase opposites attract, and that is definitely the case with magnets and static electricity. Okay, opposites attract. So a magnet has two sides or two poles. And by the way, the Earth is a ginormous magnet. Did you know that? The Earth itself is actually a giant magnet. It has a magnetic field around it. Okay, you live on a giant magnet, which is the Earth, and it has two poles. Well, what are the two poles of the Earth? They're the same two poles that are on every magnet. There's a North Pole and there is a South Pole. Okay, that is the way magnets work. They have North Poles and they have South Poles, including the Earth and including the little magnets that you have around your house. Every one of those has a North Pole and a South Pole. If I take two North Poles and try to stick them together, those magnets aren't going to want to come together because those aren't opposites. Those are the same, north and north. So they don't attract. They push apart. They reject. They're like, nope, I am not going to be your friend. And they push away. But if I bring a north, if I flip the magnet, one of them over, so now I have north and south facing each other, and I bring those together, they go, and they suck in together, they hold hands, and they clap for joy, and they're like, yay, my bestie. Okay, because north and south are opposites, and opposites attract. So you need to know when it comes to magnetism, there are two poles, a north pole and a south pole. And opposites attract, north and south, but likes don't like. That's yes. So north and south will never, south and south will never come together. North and north will never come together. They will repel each other and push apart. North and south will always come together. Now, let's talk about static electricity because it works in a very similar way, except that it doesn't have poles. Instead, it has positive charges and negative charges. So static electricity results from a overabundance or an imbalance of the number of electrons that are found in one object as compared to another object. Okay, well, what the heckins did I just say? What are electrons? So first of all, electrons are these tiny, teeny tiny little subatomic particles. They make up atoms. Atoms have electrons in them, and they orbit around the atom. But not all electrons are always in an atom. There are many electrons that are just freely moving through the universe. And sometimes they get collected in you, or in the carpet, or on the trampoline, or in a balloon. And when I get too many electrons, and by the way, you should know that electrons have a negative charge. Electrons have a negative electrical charge. We have negative charges and we have positive charges. Okay, electrons have a negative charge. Protons, which are another subatomic particle, have a positive charge, and that is their natural state. So electrons negatively charged, just like with magnetism, north and south, negative charges are attracted to positive charges. Okay, well, if I am walking along the carpet in my socks, and as I walk, I am scooping up all these electrons into my body and just gathering up as I walk around. And I end up with an overabundance of electrons in my body, then I'm going to be negatively charged. Okay. And if I go to, let's say I go to a doorknob that has a positive charge. So I have a negative charge and the doorknob has a positive charge. Well, what's going to happen when I go and I touch the doorknob? And you, I'm sure, have experienced this in your life. A lot of those electrons are going to like fly out of your finger into the doorknob to create a balance because they want to be in balance. The electrons in your body are attracted now to the positive charge in the doorknob because there's an imbalance. There's more of them in you than in the door. And so they create a little lightning bolt across your finger to the doorknob, and you get shocked. That's what getting shocked is. It's electrons leaving your body, going to something else, or possibly coming to your body from something else, if somebody else shocks you, maybe. Okay. It's also what lightning is, by the way. Lightning is just a giant version of the same phenomena with a bunch of electrons moving from the clouds to the earth. Have you ever been at night and you're in your blanket and all of a sudden you see a bunch of little lightning bolts across the blanket. Okay, a bunch of little shocks. That's the exact same thing. And the little noise that's made when you get shocked, that little snap sound, that's just a tiny little baby thunder. Okay, and the thunder that you hear outside in a thunderstorm is a giant shock, a giant snapping. The same thing that happens when you touch a doorknob. Well, sometimes the electrons can't really move. Sometimes they're restrained from moving. They can't hop from one object to another, but they're trying really hard to. They're like, come to me, let me get to you. And when that happens, it creates an attraction. And for example, the balloon sticking to the ceiling. Okay, all of the extra electrons, when you rub the balloon on your hair and you fill it up with lots of electrons, those electrons now in the balloon are attracted to the positive protons in the ceiling, but they can't quite leave the balloon. They're stuck in the balloon. They want to leave the balloon, but they can't get out of it. And so they're pulling up to the ceiling, and that is why the balloon sticks to the ceiling, because the electrons in the balloon are pulling the balloon up towards the protons, the positively charged protons in the ceiling. So what you need to remember about static electricity is that it is caused by negatively charged electrons and positively charged protons. The protons do not move. Protons are stuck in their atoms. They don't move freely, but the electrons do. And whenever there is an imbalance in the number of electrons, then you get something that is negatively charged, and those electrons reach out towards the protons, and that can create an attraction and also can shock you if the electrons actually jump from one object to another. Then it creates a little zap. Just like with magnetism, opposites attract, and just like with magnetism, likes repel. Well, when do you ever see that happening? When do you see in static electricity or the same force repelling? Okay, let's go back to the hair example. If I rub a balloon on my hair and then I hold the balloon up above my head, okay, the hairs are attracted to the balloon, but notice that they are repelling each other. And that is why every hair goes in an opposite direction from each other. That's why your hairs all stand up in opposite directions. They don't stand up together. They're not all in a clump. Okay, but they actually repel one another. Okay, just like two magnets of the same pole, your hair is all negatively charged. And so it repels every other hair. I want to call them hairlings. Hairling, like a little tiny hair. That's not probably a good word. Anyway, all the little hairlings, all the little hairs, they repel each other because they have the same charge. So again, to just repeat real quick, fields are the ability for objects, substances to reach out across empty space and interact with each other with little tiny invisible hands, but not really. They don't really have tiny invisible hands, but you can imagine it that way. Okay, and they pull or push, they pull each other closer or they push each other apart. There are different forces or fields in science that we talk about, but in this video, we're only talking about two, which is static electricity and magnetism. Magnetism has Magnetism has north and south poles, whereas static electricity has positive and negative. Opposites attract and likes repel, and that's pretty much everything you need to know about magnetism, static electricity, and fields. Well, hello. Thank you for watching my one-take rambling science video where I talk a lot and try to do as few and usually no edits whatsoever. So you hear all my ums and my awkward pauses as I try to collect my thoughts into my head. If you like learning about science, do me a favor. I have classes that I teach over on outschool.com, and you can find out about these classes by going to my website, which is Handsome Science Teacher, because I mean, look at this face, handsomescienceteacher.com. where you can sign up and get access to not only these videos, because you already have access to those, right? They're free, but also access to packets that go along with them and live conferences with me, where I teach you and grade your work and we learn together. I have an entire science curriculum from 5th through 8th grade science. Also, you are welcome to, if you would like to subscribe to my channel. That helps me too, just because it gets the word out about me.